Hey, everybody, and welcome to episode 107 of TGIK. This week, we're going to be talking about pod logging, container logging. We're going to do a little, dive back into a little bit of the detail of how all this stuff works. And then we're going to explore some of the ways to get those logs that come off of your containers to some aggregated place. And we'll probably talk about a little bit why and that kind of thing. So as usual, our notes are up at tgik.io/notes. So feel free to, play along at home if you're interested. Let's see who's with us today. Let's see here. Who's checking in with us? Maddie is with us this beautiful Friday. He's wishing George have a wonderful day, and I think that's awesome too. You both are awesome. We got Rory from Scotland. Rory, your ears were burning earlier. I had the opportunity this morning to go and see Ian Coldwater and Brad Juiceman present a incredible talk at RSA Conf, and they'll be presenting this talk again at KubeCon this year in Amsterdam. And the talk was really great. It was really about kind of different advanced persistent threats and how they work inside of Kubernetes. And so if you're interested in that sort of stuff, definitely check it out. Give them a follow on Twitter, and it was really great. But anyway, your ears were burning, Rory, because you were mentioned a few times, and it was really great. Who else do we got? We have Mike Merrill signing in from New Jersey. We've got Martin from the Netherlands. Good to see you, Martin, as always. We have Lamati telling me thanks for picking this topic. It actually wasn't my original idea. I think was it you, George? I think it was George. I came up with this one, and I was like, that's a really good point. I was really surprised we had never really hit that one. So I was like, well, yeah, I got to do that because that's a really good topic. So shout out to George. Tim Downey from Santa Monica and Mozufer Hago from Dubai. And Santa Monica, not, where did you say? Oh, Santa Monica. Is that a different place? I'll bet Santa Monica actually does exist on the planet, but it's somewhere else probably. Rodolfo Sanchez, he is signing in from, he is somebody I met last week down in Palo Alto, or maybe it was the week before, at a VMUG conference, a VMUG Leaders Conference that I was speaking at, which was really a pretty amazing experience. It was people who are leaders of virtual VMware user groups around the world, all coming together to talk about, what's coming, what's changing, and that sort of stuff from the VMware ecosystem. And that was pretty neat. Definitely enjoyed that. We got Philip Hugelmeyer from Bonn, Germany. I don't know if I'm saying the Bonn part, but I feel pretty good about the rest of the words. So yeah, let's dig into it here. See what the news of the week is. So this week we get to see Mr. Joe Bita. We should recognize him. Oh, you know what? Let me flip my camera here to the screen. Screen in face. There we go. We got Mr. Joe Bita talking about where we're headed with, and some other notable people, Pat Gelsinger, our CEO at VMware, Raghu Ragam, Ray O'Farrell, and Kit Colbert. They're all going to get together and record and talk about a launch event that kind of gives you a view into the direction that we're going with VMware and its stuff. So definitely worth checking it out. I always like to see Joe speak. I love it when he's here to actually present TGIK. But if you're interested in this sort of stuff, definitely go check it out. There is a new podcast out, and it's put together by a friend, Rich Burrows. And they are looking to start, presenting really interesting information about Kubernetes and the people who build and use it. I've been asked to be on one of them. I'm not sure which episode it'll be, but it'll definitely be a cool one. So definitely check this out if you're interested in more podcasty goodness for Kubernetes type things. We also have KubeCon is right around the corner. At the end of March, beginning of April, we will be doing, I just realized I'm going to have to change the date on something. We will be doing a KubeCon in Amsterdam, and I believe it's still on. They have a novel coronavirus update. If you're meeting people at conferences, and any conference, doesn't have to be KubeCon, feel free to bump elbows or that sort of thing rather than shake hands. Wash your hands a lot, do that kind of thing. It's a pretty big deal out there, and we want to make sure everybody stays healthy. I'm actually flying to Vegas next week, and I'm like, I'm just gonna like carry a backpack full of like Purell, and that's my plan. But KubeCon is coming up. The schedule is posted. I have a talk at the main conference talking about SecConf and security profiles and that sort of stuff. That should be really fun. I'm also co-presenting with Ian Coldwater again at Security Day, and that is the next thing we have. The schedules for Cloud Native Security Day, Serverless Practitioner Summit, and Service Mesh Con are up. So if you're interested in these things, these are day zero events. They actually take place the day before KubeCon takes place. And if you're interested in understanding more about what's happening there, definitely go check them out. That'll be really some fun talks there, kind of focused in different areas. The next one I found this week in the news was that there's this new application manager which brings GitOps to Google Kubernetes Engine. And I think this is actually pretty awesome because I've been really kind of like trying to get the GitOps stuff out there. The link is tgik.io/notes. It's actually up above Mozilla. You can find it up there. We have Ilko from Holland, and we have Marco signing in from Belgrade. Good to see you, Marco. It has been a while since you were here live. I'm glad you're here. And we got Christoph from Dusseldorf, Germany. So this application manager is like a pretty neat thing because it is actually bringing kind of a GitOps flow to deploying applications inside of your Kubernetes cluster. I was really kind of disappointed though, because it looks like you can only do this on a GKE cluster. So it's not something I can explore easily with like a Kind cluster or any other Kubernetes cluster I have around. And so I was kind of surprised by that, but it is what it is, I guess. And so I did want to call that out. It's like I thought it was great to see like more folks working on GitOps, but I am disappointed to see that this is a it appears to be a closed source thing. And if I'm wrong about that, feel free to throw a link in, but just from what I can tell, that's what's happening. Here is an example of a project that is not closed source. It could apply to any Kubernetes cluster just like the other one. I thought this was actually a pretty fun one. So this is kind of like showing how we can extend Kubernetes to support our own understanding of a problem or our own capabilities. And this is actually by this project is called Pangolin, and it's an enhanced horizontal pod autoscaler for Kubernetes. And they go into why they want such a thing. So horizontal pod autoscaling is where you have some metric that you're measuring against, and when you see that metric come along, like whether that is queue depth or whether that is IO or anything else, any other metric, or even just some custom metric that you actually expose from your application, what you want is to make sure that you have a behavior where we can grow the number of instances so that we can support the load, right? And in this way, we could have a thing where like, our minimal deployment is like maybe 2 to 4 instances of a particular application. And as we see that there is going to be a need for more of these instances, then we can automatically or programmatically grow the number of instances. So he digs into why, they dig into why they have actually developed this new solution. One of the neat things about it is that it uses Rust. The requirements are pretty recent though. You have to have a Kubernetes 117 cluster with RBAC enabled, and the target deployments or pods would have to have Prometheus metrics available on port 9090. So it looks like maybe it'll be scraping those endpoints directly, which is kind of interesting. They have a good demonstration here. So if this is something that you're interested in, definitely check that out. But again, I kind of really appreciate how this is open, and anybody can go look at it and play with it and see if it resonates with them, or maybe even contribute. The next article up, I have a really good article by New Vector. And New Vector actually have been doing a lot of interesting articles in this space. So their blog is actually pretty decent. This one is actually how to optimize for IO-intensive containers on Kubernetes. Now, what's interesting is that by default, Kubernetes doesn't really spend a lot of its time trying to police the IO between containers, right? We have quota for memory and for CPU, but what about IO? And so definitely check this out. This is a very good article, I thought, and which gets into it. And they even get down into some of the primitives. They actually talk about like the different CPU schedulers that are scheduled, that can be used on the underlying node, and how those things have an effect with relation to tasks that are running inside of Kubernetes. Thank you, ABC123. I appreciate it. Oh, selective information like CS. Maybe I misunderstood. Okay. So yeah, like they get into some really good details. They have some really good thoughts about how it works, and they have a really good article here put together about how to approach this problem, which is definitely worth a check out. So go back to our notes here. We've talked about Penguin, talked about I/O intensive containers. Oh, okay. So when you contribute a project to CNCF, lots of great things happen, including the ability for CNCF to host webinars on your project and actually kind of like help get the word out. So what's fascinating about this talk is you can even tell already from like kind of the how-to or the information here on the right that this is a developer advocate, Helm maintainer, some interesting ampersands, and another developer advocate from different companies all getting together to talk about an open source project called Helm. But, oh, I might sneeze. No. All right. Oh, not sure if I'm going to sneeze. Okay. All right. I'm back. Sorry. The neat thing about this is that they're actually doing this webinar on kind of talking about Helm, verifying Helm installations, talking about signing and verifying Helm charts, detecting and fixing vulnerabilities in container images, which is probably the SNCC stuff. And then we have Kubernetes security in your charts. And they're also digging into kind of the security model of Helm itself. And so it's definitely worth checking out. It has changed a lot. Introducing Helm 3 really changed this quite a lot. So if you're interested in understanding more about Helm 3 and how it works, we're going to be playing with it in this episode, but definitely worth checking it out. Now, as I was looking at that one, I also noticed that there was this article that came out on February 26th. That was an overview of Fluent-D, which is another project that has been donated to the CNCF. And Fluent-D and fluent-bit are kind of the two different solutions that fit the same need, and they even have a very consistent way between them of solving this problem. So Fluent-D and fluent-bit are very similar. And we'll talk about the differences here in just a minute as we get into the actual episode here, about what the differences are and that sort of stuff. So it'll be really fun. I think it'll be a fun talk. But if you're interested in seeing that or reading a little bit more about what the CNCF or this particular contributor, Bran Rubinsoft, has to say, definitely go check that out. It's a good talk, or it's a good article, I should say. All right, that was all the news that is fit to print from the cloud native landscape. I'm sure there's more stuff out there, but I wanted to make sure we save enough time to get through the content today, and it'll be a fun one. So let's get this kicked off here. All right, let's check the notes, see how everybody's doing. We got Morteza from Tehran. We had Eduardo Silva, who is one of the authors of Fluent and fluent-bit, I believe. I believe in both, but I was working with Eduardo to understand a little bit more about fluent-bit. So they are awesome, and I'm glad they are here to chat about this stuff and answer questions as we come along. What else do we have? We got Zolt from Finland, fluent-bit only. So Eduardo works on fluent-bit only. Great. We have Bradley from Leicester, UK. And all right, well, that's everybody. So let's get started here. Let's see what we got. All right. So first I want to go back a little bit, and before we start talking about pods and log aggregation and all of that stuff, let's talk a little bit about like how it works and why it works that way, right? So let's flip over to our terminal. So containers really kind of change the way that we think about logging. And this is actually one of those truths about containers that I think, bothers some people and doesn't bother others. But I want to make sure that we think about it. Oh, thanks, Roy. I like that one too. It's like it's almost like the Iron Man logo for the Tanzu stuff. But what containers do for us, or the way that they actually kind of inherently solve logging, is that they expose standard out and standard error from the container, and they throw this stuff into, Stephen. They throw this stuff into files. So let's take a look at how that works. Kill me, buddy. So varlib, docker. So And I would do it again. All right, so inside of varlib docker, that's actually where we're going to see the output of of all of the containers that we might have running at any given time, right? And so if we look at these, logs, this is information about the container, including the output of its logs, right? So this JSON.log file that is associated with that particular container, this guy here, is actually the capture of the standard out and standard error from this particular container, right? And so if we do this, let's see, docker ps -a. I'm going to go ahead and clean up my Docker environment here real quick, just to make sure we're clear. So Docker, what is it? Docker system prune all volumes. Yes. Clear. And then Docker ps, Docker stop. Run the other command again. Yes, clear. Okay, so now if we go to varlib docker containers, we see no containers. All right, so let's make one. Docker run bash bash. Okay, so here we have Docker, we have bash running, right? And we can do echo this to, then I'll go to standard out, and we'll do echo this to. All right, so exit. Now we see our container that we created. So that's our container that we just created, and you can see that long string is actually related. Docker ps -a is related to the long string that represents the container ID, right? So A94D87 is actually that long hash that represents the actual container ID. And if we go into there, we can see our log file again. We did not get anything out of the log. Our log. I wonder where I went wrong there. Let's try this again. Docker run nginx. What I should have done was Docker ps var log varlib docker containers. Oop. Containers. Oh. Docker log. So we see our nginx instance running, Docker logs. Something is wrong with my setup here. I should be able to see the log output there, and I'm not seeing it. Okay, well, that's odd. I think maybe I messed up my configuration somehow. Yeah, but I should also be able to see it like loading up, right? Like it's a daemon that's actually catching that stuff. So you know what? I have a different idea for an image. So we jump out of this. Oh, but I can't yet. So pop it up in a new tab. And then we'll do docker rm-f. Clever. All right, clear. This was actually a pretty cool thing I thought I found here. Grep-ir image star. Where's my image name? Cat values. Bonsai log generator tagged 032. Okay, so docker run. This is a log generator we're going to use later in the show, so let's try it. Let's go ahead and try it now, because what this does is basically just generates logs for almost exactly this reason. So now we can do docker ps, and we can do docker logs. We can see the output, and it's just generating logs constantly to the output, the standard out or standard error of the container. So now let's see if we see what we expected to see before, because this will be the interesting part. Lib, docker, containers, cat. There we go. All right. So it is wired up right. I'm just doing something wrong. If you send data out to the, oh yeah, sorry, my bad. So docker ps, so docker. I've started this container image called Bonsai Cloud's log generator, and what it's doing is it's literally just kicking out a steady stream of logs into standard out and standard error. So if we were to do docker logs -f busy Lemire, we would see what the output of that log looks like. And this is just a dumb little process that is randomly generating logs and kicking them out to the output. We're going to play with this more later, but effectively that is how containers handle logs. So if you're used to running, some other application that handles logs differently, like maybe a Java application or one of the other applications that are, or pretty much any other application that you might write, if your goal was instead to persist your logs to syslog or persist your logs to a file sitting on disk or those sorts of things. The world has kind of changed when you start using containers. You have to think about making use of standard out and standard error instead of making use of those older mechanisms. And the reason that's important is because it wires up to the way that containers log standardly. And it also gives us the ability then to think about handling the logging problem. Like, how do we actually aggregate those logs? How do we get them off the machine? How do we present them to our developers? And that sort of stuff, kind of in an easier way, or in in a way that results in less friction. So I'm going to go ahead and stop this container because I don't want it to fill up my disk here. Docker ps. Okay, cool. So that is our test container. It shows how containers work, and pods work much the same way, right? Like if I was going to look for the log for a pod, it would work the same way. So let's go ahead and try that out. So I've created this environment just to kind of play with it. And before we actually get too far here, I want to talk about what is configured here. So this is the config of the cluster. I'm using a kind cluster like usual. You've all seen me do this a million times. In this cluster, I'm going to create one control plane node. I'm going to create 3 worker nodes, and I'm going to deploy an elk stack to this cluster, and I'm also going to do some other interesting things. Before I get too far with it, though, I want to make sure that we understand. Oops. Varlog Kubernetes. All right, good. I want to make sure we understand what's happening here kind of in the background. So one of the things I'm actually doing to this particular cluster is I'm also configuring it to handle audit logs, right? I want to make sure that the audit logs are coming out of the control plane node and being persisted to disk in the form of a file called varlog kube API server audit log. And I just caught a typo, so let's fix this real quick. Maybe I'll see that typo. I do. Boop, boop, boop. All right, so my configuration, I've got a few kind of interesting things happening here, right? I've got inside of kind, when I'm defining that node, I'm describing an extra mount. And that extra mount means that inside the container, I'm going to mount that file at etc Kubernetes policies add-audit.yaml. And on the host, my laptop, I'm actually going to put that file in temp, just so it's easy to find. And then I'm actually going to grab that file from the etc Kubernetes policies directory, and I'm going to load it into my API server as part of a policy file, and have my API server output the API server audit log to disk inside of the control plane node. And I've actually also set audit log format JSON. And we're going to get to why I'm doing this, but really what my goal here is to make sure that I can make certain that the audit log, is being kicked out in a way that I can then go and scrape it with fluent-d. They're not mutually exclusive. It's true. Fluent-bit and fluent-d are not mutually exclusive. That's a very good point. Is this better for containers than fluent-d? We use the UGSAC and Logstash. I wouldn't say that. I mean, they each have their strengths, and we'll talk a little bit about what they are here in just a minute. All right. Okay, so let's get this kind cluster created. Create cp temp kind create cluster config. If only I could type. Config equals we're going to show logging for pods. We're not there yet, so we're going to come back to them. But on the fluent-bit documentation page, which is here, we can dig into about and talk about a little bit what it is, right? And here, I think they actually do a fairly reasonable job of describing kind of the difference between the two. They both actually are functionally very similar. They're very flexible in the way that you can configure them. They lay out a stream processing mechanism very similar, right? It is a log collector, processor, and aggregator. Actually, fluent-d is an aggregator. It doesn't have that feature inside of fluent-bit. But the way that they lay these things out, and we'll talk about them a little bit when we get into configuration, is the same, right? You have inputs, you have filters, you have ways to manipulate the data that came from the input, and then you have outputs, ways to get that data out toward your given destination. Now, some of the stuff that's changing, right? So Fluent is written in C and in Ruby. It takes quite a bit more memory. It is high performance, but it does take, depending on like the amount of data that you're moving in a second, it can really kind of feel the burn. Fluent-d is built as a Ruby gem, and it requires a certain number of other gems. One of the big secret superpowers of Fluent-d is that it has more than 650 plugins, which means that very likely whatever that stream of data, whatever that input is, whether that input is like related to logs coming off of a systemd unit, or whether that input is related to logs that need to be parsed as part of the Kubernetes logging, right? Or pretty much any other obscure thing you can think of, right? The plugins that are here in fluent-d give you the ability to really customize the different ways that the input is handled, that the processing is handled, and that the egress is handled. Like, how do you send it out, right? Whereas fluent-bit has 35 plugins available. It is not completely compatible with all of those plugins, but it is also going to take significantly less memory. It's written from the ground up in C and is meant to be very, very much more performant than the other, right? So the performance of fluent-bit is like pretty extreme, but you're also constrained in what you can do with it. And so as long as fluent-bit satisfies the requirements for what you're trying to achieve, like in my case, I'm just trying to achieve making sure that I get all the logs from all the containers inside of Kubernetes. I want to do some manipulation of that by making sure that I have enough metadata when those logs show up in my aggregation endpoint that I understand a little bit more contextually what's happened with those logs. And then I want to kick them out to, in my example here, we're going to use an elk stack to kick them up, right? So we're going to output to Elasticsearch. So fluent-bit checks all those boxes for me, and that's actually why we're kind of exploring it. They're both Apache 2 licensed. They both have been around for a while now. There's a pretty major release coming up of fluent-bit that Eduardo is working on. But I think from my perspective, that's kind of like the high level why one over the other kind of thing. But yeah, neat stuff. So let's see how our cluster's doing. Cluster's up. So Docker, or actually, kubectl run to. I'm going to look for looking for that image again. What was it called? Log generator history. Grep generator. So this is our image. So we're going to go ahead and deploy that on our Kubernetes cluster. Run log gen. Anybody catch my typo? I'm always typoing. Y'all are so patient with me. All right, so kubectl get pods. So now I see my my pod is running. It's a pod of only one container. It is the loggen container, right? And if I do kubectl logs, we can see the logs from that container running. Yeah, that's true. Yeah, in 2011, definitely. And if we jump in here to our, let's see, kubectl get pods -o wide, we are running on kind worker 2. So if we jump into our kind worker 2, oh, that's weird. There's no varlib docker. So I wonder how that works, right? But then I remember, you know what? In kind, we use containerd, not Docker. So we still have to have some way of actually handling that. Does containerd handle logs in a similar way to Docker? Let's take a look at that real quick. So if I do crkettle ps, I can see the containers that are running here. There's my loggen container, right? And if I do crkettle inspect the container, the loggen container, we can see the cgroups path. We can see the output. We can see the service account being mounted in. We got resolve.conf host name. There is the termination log. That's the hosts. There's our image, and there's our log path. All right. So it's going to send the output of this pod to this path on the underlying disk, var log pods. So let's go look over there and see if we see our output, right? I mean, also we could do crkettle logs-f loggen. Oh, no, sorry. So we have our image name, logs-f. So we can see our logs just output just like we can with Docker, right? Just by using crkettle instead of using Docker, because we don't have Docker installed, we only have containerd. But we saw the output of our log. We saw our path to the logs, which is var log pods. And if we cat that, we can see that that is also persisting the output of logs from the container, or from the pod, from the container running inside of the pod into our underlying file system, right? It's running into var log pods. We also see it output into var log containers. And if we do an ls-l here, we can see these are just symlinked. This symlink, I believe, is being done by, it might be Kubelet or it might be done by Containerd itself. But the actual containers, if you had multiple containers per pod, you would see the output of each container's output here in this output, right? And you can see that it's just linked into the actual, the varlog pods path. So this is basically where we store these logs on the underlying disk. And it raises an important question of how long do these logs stay around, right? So if I do Sierra Kettle PS, Sierra Kettle stop. So now I just changed that, right? So now the loggen is a different ID. So the question is, how long does the old one stay around? We still see both of them here. We see how we still see our A176EE, and we see our B880DB. Now, what's interesting about this, I wanted to show you this other cool thing. If we do kubectl get pods, we can see it's running. We had one restart. One of the cool features that I really like about kubectl is that you can do logs-p for previous, and then point to that pod, and it will show you the previous log. So if you have a pod that is actually failing, you can actually use kubectl to see what the previous logs are. So we'll keep those previous logs around for a bit. But let's go ahead and do that same command that we did, but let's do it a couple more times. So crkettle ps, let's go ahead and stop this guy again. crkettle stop, crkettle ps. Change it again. Let's do one more time. Stop. Yes. And then var log containers. And we can see that we only have 2 around, right? So what we just noticed here was that the actual logs, it only keeps the previous one and the current one around. It doesn't keep the ones before that around. But what if there was information in that log that was critical to me, right? Like I didn't notice that it was failing over and over again until just recently, but I want to be able to go back and see what the logs are. I want to understand why it failed earlier to be able to really dig into what's happening. So let's take a look at our chat, see how everybody's doing. I know I'm talking a lot and I'm covering a lot of deep detail, but I hope it's useful to folks. We got Eduardo. Fluent, the original author, is a strong C, C++ Ruby developer. Actually, before Fluent, he created message pack, a binary serialization data format. Yeah, totally. He wrote it in Ruby because it was the initial POC, but it did really well. It sure did. A lot of people are still using Fluent-D, and people started creating plugins for Ruby Fluent-D, which is actually pretty killer, right? Like, I mean, that's kind of the really neat thing about the Ruby piece is that people feel comfortable contributing to it, right? Getting those things out. So there's not going to be a varlog Docker in this one, Mozufo, because there's no Docker. There's just Containerd. So in this case, it's actually just going to be inside of Containerd's output. We got everybody being pretty cool, so let's keep going. All right. So like I said, these container logs don't stay around forever. And so the important thing is that if you're going to actually use these container logs to debug things that have happened over time, then you're going to have to make sure that you get these container logs off the system. And that brings us around to how are we going to solve that problem. All right, let's kick back over here. We talked about logging for pods. Oh, there's actually one more problem that I wanted to highlight. And this is actually, I mean, we kind of did, right? The problem is that these pods are ephemeral. They change a lot. And when they change a lot, that means that these logs are going to get deleted from the underlying host. There is actually, for the actual containers, there are some tweaks on the kubelet to manage the amount of logs it'll keep around and that sort of stuff. But typically, what you really want to make sure is that you actually get those logs off the host. We talked about where pod logs go. We talked about how long they stay around. We talked about kubectl logs-p, which is one of my favorite logs commands. And then how do we get them off in choice of aggregator? There's a ton of tools out there for this. I really am a fan of the Fluent stuff because it actually, for a number of reasons, Fluent-D was contributed to CNCF. There's a lot of really good stuff. So cool. So now, before we get into the fluent-bit docs, I want to actually go ahead and deploy some stuff, and I want to show you how I'm going to go about deploying that stuff. So let's go play with that. So, Kubernetes. First things first. I don't know if you all know this, but there is a add-ons to Kubernetes. And let's go ahead and explore some of those real quick. So before we go there, let's go check this out. So if we go to the Kubernetes cluster add-ons, here we are on the Kubernetes repo, and inside of underneath Kubernetes cluster, there is a directory called add-ons. And add-ons are kind of the things that you have probably played with before. There's lots of good stuff in here. The dashboard is hosted here. The device plugin for NVIDIA GPU, the horizontal autoscaler for DNS. The DNS plugin, Core DNS, is actually hosted here. RBAC is hosted here. A bunch of the different stuff is actually hosted in this case. But the one I really wanted to show was this one here, the Fluent-D Elasticsearch add-on. And as you can tell, it's like 3 months, some changes, 2 months ago, those sorts of things. It's actually continuously updated. But what this Elasticsearch one does, and it has lots of big bright warnings about don't use this in production. But what it does is it actually is a maintained way of deploying an EFK stack where we deploy Elastic, Fluent-D, and Kibana, and then we can actually kind of explore the way logs work inside the cluster. Now, the other thing that's neat is because it's part of the Kubernetes bundle, it's part of the package that is actually provided by a Kubernetes release, we can download this content by using this pretty neat trick. curl-lo, DL for Kubernetes for download, k-io, and then the version, 17.0, and then the name of the file. In this case, it's going to be kubernetes.tar.gz, creative, I know. But what this does is it pulls a tar file of those things, including things like the add-ons, right? And so now if we do tar-xvdf of the Kubernetes tarball, we get a bunch of content, including kind of all of the add-ons and everything else that are related to the main upstream kind of piece. This stuff hasn't been moved out yet. So if we go into Kubernetes clusters, add-ons, there is all of the manifests associated with that. So there's our Elasticsearch. Now this setup will actually deploy Fluent-D, it'll deploy Elasticsearch, and it'll deploy Kibana. I'm going to do a little trick here. -ir image star.yaml. Print $3. Bear with me for a second. I'm going to get a little hacky here. Don't want that line. So these are our image names. And the reason I'm doing this is because I want to be able to cache those images on my nodes before I try and deploy them. So this is actually kind of a kind trick. So let's play with that. So let's do cat images xr minus I. Give it the object that we're going to change, and we'll do kind load Docker image. Oh, actually, first we got to do this. Docker pull. So let's pull these images first, real quick. Some of these are huge. Like the Elasticsearch image is ridiculous, which is why I'm pulling it locally here. so that we don't have to wait for each individual one of my nodes to pull this image, because we would be here for way longer than I want to think about. But because we're able to pre-pull these things, and then I'll be able to use Kind's load image capability to push that image into the cache on each of my nodes, we won't have to wait for that image pull to happen, and that'll really cut down on the time it takes to get these things spun up. This is actually a really cool trick that Kind lets us do. So we're going to go ahead and finish pulling these out, and then we'll push them in there. Got our Kibana downloading. All right, so now we got all of our images, and they're local on my machine. If I do Docker images, I can see them here, but now I want to get them on all of my nodes, right? So now if I do kind get nodes, right? Okay, so cat images, and then we'll do xargs minus I. We'll give it the argument name, right? Then we'll do kind load Docker image. It makes a bunch of assumptions here with that simple command, right? It's assuming that I want that file on all of my nodes. And it goes in and it takes a look at the containerd image list and sees if that image is present. And if it isn't, it copies it in. It can push to Kafka, it can push to Elasticsearch, it can push to a bunch of different things. Marco, it was good to see you. I'm glad you were able to join us for as long as you could. Please enjoy the awesome weekend. Thank you very much for your time. So now we're just pushing our images in, and now when this completes, we're going to have all of those images hosted on all of our nodes, and then when we go ahead and deploy this stuff, we will have all of that stuff, kind of in the cluster. Now these are techniques that I use to actually, bring up test clusters when I want to actually explore how things are going to deploy, right? So what I've done is I've pulled my images, I've put them all in there, and then we're going to actually deploy fluent-d first because it's part of this set of manifests, and then we'll probably pull fluent-d out and we'll deploy fluent-bit and we'll compare. So let's do kubectl apply -f dot. And this goes ahead and deploys a bunch of stuff. Does that sound like bad? Really? That happened last time too. Hold on, let me fix it. That's frustrating. Sound settings, output, input. Is that any better? Can you all hear me any better now? I just made some changes. I hope that's better. Okay, good. Yeah, all right, cool. Sorry about that. Having some sound issues still, but anyway, let's keep going. So we've got that deployed. Let's take a look and see what we got. Pods -a. And what we've got so far is we've got a Elasticsearch logging daemon set running in the kube system namespace. And we have, the first one is up. We're looking at bringing up a second one. We have the fluent-d daemon set deployed. We have Kibana running, but it's not completely running yet, probably because it's waiting for Elasticsearch to work. It's deploying all of this into kube system. Waiting for things to come up here, initializing, and running. -n kube system -v running. So we got everything running. kubectl get pods -n kube system. Waiting for this one to come on happy. Let's do kubectl get pods -n kube system. Get that one. Oh, and there, and now it's happy. All right. So let's do kubectl proxy. This is just how they've set their stuff up. Oh, kill all pgrep proxy pgrep. Apparently this one left this one around from before. It can't possibly be proxying to anything. So let's do that again. Kick up our proxy. There we go. So now we're on 127.0.0.8001. So now I want to actually connect to that service that is defined by the Kibana service. So let's do kubectl get svc-n kube system. And we see our two important services. We have our Elasticsearch logging service. We have our Kibana service. First, let's actually see if the Elasticsearch logging service is working correctly. So we'll do kubectl get svc-n kube system, Elasticsearch, grep self. -o YAML. The reason I'm grabbing this is because I'm going to use a kubectl command to interact with that service using proxy. So let's do kubectl get raw proxy cat indices. And we can see that there is an index for Kibana, but I was kind of hoping to see an index for Logstash. Ah, there we go. All right. So now what we're seeing is kind of what I was hoping to see earlier. So these indexes are actually indexes that are hosted inside of Elasticsearch. And we're seeing, oh yeah, that's a really good question, Fernand. And I will answer it, but not yet. So, so now we see our two indexes. We see a Logstash index and we see a Kibana index. And the Logstash one is actually being propagated by our Fluent configuration up to Elasticsearch. And we can see it there. So now we know that that's working. Let's go ahead and connect to the Kibana UI to kind of like play around and look at the logs there. So let's do this. So let's do the same command again, get services logging, but we're going to look for our Kibana one instead, right? Kibana logging. That's our self link, and so we'll do xdg open https 127.1:8001. That is our kube proxy port. We're going to kick this on here. We're going to proxy. And what this is going to do is it's actually going to proxy us. It's going to open a browser, because that's what xdg open is going to do. It's like a magic Linux command that will open the file or the thing that you hand it. Because this is a URL, it's going to open it with my native browser. Let's try that out. And then we'll click over to that. Hey, we got Kibana. All right. And so what we're doing here is we're actually just connecting to the proxy of the actual application. So this is the application has defined a port that has defined a port as part of its service. kubectl, the proxy command, can determine, okay, well, there's only the one port exposed by this application, so we will connect you to that application's port. And here we are looking at Kibana. So now we're going to do the next fun part, and we're going to look at the create index pattern page. And we're going to see there's a couple of different indexes here. There's one by date called Logstash, and there's also a Kibana one, but we're going to go ahead and grab the Logstash one. We'll do next step. Our time filter will be timestamp. And this is all of what's built into, all the fields built into the what do you call it? The fluent-d configuration that is hosted on as part of the Kubernetes upstream content, right? So we have fields like Docker Container ID, Docker Container Keyword, Kubernetes host, Kubernetes labels, all kinds of information, all here. We can actually see quite a lot of fields represented here. And now if we go back to our inspect, we can see the logs that are present on our cluster. Right, so this is all aggregated logs up from the cluster. And so just as we saw before, now we are actually aggregating these logs to an Elasticsearch engine. If we were to rotate that pod again a few times, we wouldn't lose the stream of logs. Oh my gosh, I hate audio so much. Is it still bad? It's just high pitches mainly? Okay. I can try and reset it again, but let me know. All right, well, I'm gonna keep going. So these logs are now off the node, right? These nodes are well, sort of. So these logs are now in Elasticsearch. The Elasticsearch is actually hosted on the node, so it's not completely an answer. And in fact, it raises a very good point, wherein if you actually did host Elasticsearch on the cluster and you lose the cluster, then you also lose the logs. And so that's going to be hard to troubleshoot, which is a really good argument for actually either hosting Elasticsearch on some centralized cluster or on a number of clusters, or using some other service to actually host that log content. Don't host it locally, right? Like that's the point. Is if the tools you use to debug a cluster are all hosted on that cluster, and the cluster is misbehaving, you have discovered one of the many foot guns, right? Make sure. All right, so cool. So like I said, now our logs are disconnected from the underlying host, so we can actually see them, and that's great. So that is fluent-bit, but before we go too far, let's go ahead and take a look at how fluent-bit is configured, and then we'll jump over to fluent-d or fluent. Let's take a look at how fluent-d is configured, and then we'll take a look at how fluent-bit will be deployed. And we'll pull fluent-d out, and we'll put fluent-bit in. So, click over here, and then we'll do Octant. Light. So this is Octant. Octant is an open source project we work on here at VMware, and it gives us kind of a visual tool for looking at how things are working. I'm going to jump into the kube system namespace because that's where our fluent-d configuration is hosted. We can see we have a few things. We have a daemon set, which is fluent-d, and that's what I wanted to look at, was like how that's configured, right? So if we look at how that one's configured, we see a couple of different things. We have var log exposed up. We have varlib Docker containers, presuming that it's, oh, but that's interesting, right? Because it's actually mounting a directory that doesn't exist on the underlying host. We were just noticing that earlier. If we look at the nodes here, there is no varlib Docker containers, but there is a var log containers. Let's take a look at the configuration. So then we have our fluent-d ES configuration, and it's hosted in a config map. So let's go look at that config map and see what that looks like. This is probably not the best way to read this. So let's just jump back into our terminal, because that's how we roll around here. Okay, so kubectl get config map -n kube system. -oeml. All right, good. So that will actually parse better. All right. So here's our configuration for fluent-bit. And like I said before, the way that fluent-bit has I keep saying fluent-bit. Right now we're looking at fluent-D. In the future, we're going to look at fluent-bit. We're not to the fluent-bit part yet. But much of this will look very similar when we get to the fluent-bit part. In this case, we see our input conf, and it describes, it's a pretty well annotated file here for describing exactly how this is configured. It has examples of what it's trying to parse and information about what it's actually looking for. But let's get down to the configuration. So we've configured a source, right? And we're looking at var log container star.log. And that is interesting because it is exactly what we were looking at before, right? So this is a type tail, which means it's going to tail all of the files that we described by this match. And so on the underlying host, on each node, inside of var log containers, I have all of those container outputs, right? And we can see the logs there. And we can tag these things, and we can have a position file. So if our Fluent process comes to an end or gets restarted or runs out of memory or what have you, it can actually come back and continue on where it left off. And I've had problems with that one before with fluent-D, where the position file gets corrupted and it had a hard time like picking it up again, but that's an interesting thing. We have a pattern that we're expecting the log output to look like. We have exceptions that we're looking for. We have, and this is the filter, the ability for us to manipulate that data. So if we see log lines that don't look quite the right way, we can actually just forward them off in one single line. We have filters where we're going to actually try and understand if it's a multi-line piece or a multi-line log message, and if it is, we're going to try and again concatenate it into a single line. And then this one is a really cool filter. This filter, and this works on Fluent or fluent-bit. This filter actually gives us the Kubernetes metadata as part of each log line. So when it's aggregated up into Elasticsearch, we have that context, right? So before, when we were looking at our Kibana output, right? Look at all this metadata that we have for just this one message, right? Oop, dang it. Boop. So look at all the metadata we have for this one message. The fact that we have the container image name, the image ID, the container name, the container host, the labels that are associated with it, the master URL that is in the environment, the namespace ID, the namespace name, the pod ID, all of this information is actually added to the log line, right? When it pulls that out of the file, it's actually adding, that filter is actually adding all of this Kubernetes, this metadata to the content before kicking it up to Elasticsearch. And that is killer, because when you're debugging, right, you need that context. And that's actually, I think, one of the coolest features of this whole Fluent thing, is that you can actually manipulate this data in a way that makes it more contextually relevant to you when it hits the log aggregation endpoint. That is a killer feature. We have things that are going to try and fix the JSON fields. There's a bunch of other material here that is just manipulating the content, looking for a Prometheus exporter, looking for inputs. The input here is pulling from Prometheus, but a bunch of other content here that is actually pretty cool stuff, right? And it's even got a buffer. And so it's actually, so this is the part where we're sending the output. This section here is output. We're going to send it to Elasticsearch logging. Now, this may not look super consistent with the way that we name things, but if you think about it, the service that was exposed that we interacted earlier with to see the indices, right? The service that we saw exposed was Elasticsearch logging. And because in this case, fluent-bit or fluent-D is deployed within the same namespace, it can route that traffic just to the service name because they're both in the same namespace. If I put this in a different namespace, I would have to use a bit more context. I would have hostname actually have to be the IP address of that service, or possibly the more complete name, elasticsearch-logging.cube-system.svc would do it. What port to listen on? It's log stash format. Actually, this is how it determines its name too, right? And so that's how we're handling it. And we're also grabbing the systemd is it a system conf, and we're grabbing the system input. Bunch of other examples in here. Trying to pull logs from etcd log, which is actually pretty interesting. Var log, etcd log. I'm not sure if that's actually present. We'd have to look at that, but it's actually also trying to pull a log from the var log kubelet log, which I don't think is actually even there. Let's take a look at that. Worker bash c var log. Here's the es kubelet log. So there's our log file for it, but I don't think it's actually exposed in the way that they think it's exposed. And so we can't even really see it. Also, we have this idea of journal. That's cool. All right. So we see, maybe this is actually where it's getting. It's probably getting the journal log from the kubelet from the configuration of journal D, right? So as part of the input here, we are probably looking for system D. Yeah, there it is. So we're looking logs from the Docker service, which we will not see because there is no Docker service. We're looking for logs from the container runtime. We're looking for logs from the systemd unit for kubelet service. So we are actually aggregating these logs up, and that's pretty great. If we had node problem detector deployed, we'd be grabbing that. We're grabbing logs from the kernel. We're getting a bunch of really good logs here. And so again, if we jump into our Discover data, let's see if we can find logs from the kubelet. Doesn't appear so. So that is interesting. And we'll talk about why that is. But the reason I think that that's happening, right? We're not getting the content from the tag kernel. We're not seeing that content. So we do tag. Zero documents. Zero documents. So what's happening here is we're not getting that systemd data up. And I figured out why this is, but it's kind of a wild thing, and troubleshooting wise, it's a fun one. But we're going to get to that when we get to the fluent-bit piece. So let's go play with that. How are you all doing? Are you feeling good? Are you having a good time? I hope this has been pretty interesting so far. Let's go ahead and play with this stuff. So I'm going to go ahead and uninstall the fluent-bit stuff, right? So if I go into my Kubernetes stuff where my manifests were, cluster, add-ons, Elasticsearch, it's called fluent-d Elasticsearch. And I'm going to do kubekettle delete -f fluent-d stop. ts.yaml config map. Okay, so now if I do kubekettle get pods -n kube system, I don't see any more fluent-d installed. They all have been deleted. All right, so let's go ahead and play with the fluent-bit piece. And then when we do that, I want to dig a little bit more into how fluent-bit and that kind of stuff works. So let's play with that. Boop. So here is our documentation for Fluent and fluent-bit, and we're going to go ahead and we're going to play with like the the installation method for how to do this. This is one way to go about it, but they also have a Helm chart. Here is a way if you wanted to just deploy this thing manually from a set of manifests. You can see them here. And I highlighted this earlier when I was playing with it. Extensions v1 beta 1 has been expired. And so if you're going to deploy to a cluster, a newer cluster, you have to make sure you use apps v1 API version instead of the 1.16 stuff. You've all seen me kind of hit that one a few times. Consume all container logs from the running node. Tail input would not append more than 5 meg into the engine until they are flushed to the Elasticsearch backend. This aims to provide a workaround for backpressure scenarios. Some details about how it works. Pretty cool. Kubernetes filter will enrich the logs with that Kubernetes metadata. That's what we talked about. The default backend configuration is the Elasticsearch by the Elasticsearch output. Now, what I noticed when I was looking at this stuff is that their content is also available in the Helm chart. But before we go there, let's just walk through the getting started stuff and just better phrase like how this stuff works. Now, a lot of this is going to be very similar, whether it's in fluent-bit or fluent-d, right? So a lot of these things are very similar, but this is actually kind of how it's laid out. And I want to talk through this real quick. So as I said before, you think about it like stream processing. You have your inputs, where you're getting the data. And the one that we've seen so far was about getting data from log files. So we use the tail mechanism to get that input. Then we have a parser. How do we convert this unstructured data into structured data that we can kick it up into Elasticsearch and make it a usable log line? And in some of the examples from the fluent-bit side, we were actually using a parser to, make sure that if it was a multi-line log file, we would try and catch it and turn it into a single-line log file. We were catching things like making sure that when we pull these things apart into fields, we understand which field is the timestamp and which one is the severity and which one is informational and that sort of stuff. And we have our filter, which gives us the ability to alter that data. This is like the really killer one is actually the Kubernetes option, right? Like the ability to actually concatenate or to integrate all of the metadata for each of those log lines as you're kicking it up to Elasticsearch with metadata about that log line, like what container it's from, all of that good stuff. We have a buffer, which is really killer. Like this is a really good idea and really definitely worth it because if you think about it, like, what if you had a couple misbehaving apps that were just spewing logs to the disk, right? Now, obviously, we need some way of actually handling a buffer so for backpressure scenarios. And so we want to make sure that this buffer really helps us out. It means that if we are producing logs faster than Elasticsearch can ingest them, there's not going to be a situation where we overrun Elasticsearch or we lose content, hopefully. But it gives us the ability to manage it. And then routing, data ingested by an input surface is tagged. That means a tag is assigned, and this is used to determine where the data should be routed based on a match rule. So right now, we only have the one routing rule. We're kicking it all to Elasticsearch. But what if we had a different problem? And we'll talk about it here in just a minute. And then the output rule. The output basically defines the destination. So this is the general layout of how fluent-bit and fluent-d work. These are not different, particularly in this way, right? Like this idea of multiple outputs and handling routing and buffering and all of the stuff we just saw in fluent-d is actually very similar, if not the same. And there are a bunch of built-in options to handle these things, right? So if you click on any of the inputs, you can see what some of the input plugins are, right? So for example, we can pull input from collect. We can listen to collect D, CPU, disk information. We can exec and get content. We can listen to the kernel message log buffer, and then the tail one is actually the one that we found use for here. And there's also a systemd one, which is actually pretty cool. Be able to interact with systemd, leveraging journally to pull logs. And if you have an older Linux system or one that doesn't use systemd for those logs, you could also pull from syslog. There's also a serial interface. I mean, like, really I mean, just this small list of plugins accounts for quite a huge capability of getting data from different sources into this tool that allows you to handle that stream processing and get it routed out, right? And the same thing for the parsers. There's different parsers. We have collect D, different ways of actually parsing the content. And again, like, just ways of understanding what the fields will be and like in what order they come, right? So we have system D, we have syslog, just different ways of understanding how that data will map. We have decoders. Parser name is Docker, and this is kind of the expected way that Docker is going to lay its data out. Then we have our filter plugins. The one we talked about already was Kubernetes, but there's also quite a lot of things that you can do with like different parsers and different Luas for the filter side of things, including our Kubernetes, including grep. I mean, definitely pretty powerful combination of things. And then the output plugins. Do you want to send it to the Azure Log Analytics, to BigQuery, to Flow Counter, to Elasticsearch, to a file, to Datadog? Like, there's a lot of really great plugins here. And these are all the ones that are just built into fluent-bit. Now, as we said before, if I were to pop over to the fluent-d side of things, the number of plugins over there is even crazier. So fluent-d plugins. List of plugins by category, right? So these are the plugins for fluent-d. I'm not going to spend any more time on this page, but I wanted to kind of show that like there's a ton of plugins here that are hosted and managed by different authors as it relates to fluent-d. So if the case you have is getting these logs processed in a more unique way, where the tools that fluent-bit expose, which are very powerful, don't quite solve your need, or maybe you're just taking the easier route and you see, somebody's already solved my problem. There's already somebody who has an Aurora slow query log. I just want to use that plugin to solve my problem, right? Fluent-d might be a better solution for you than fluent-bit. But if what you're trying to do is just handle mass amounts of stream data into a Kubernetes cluster and get it out into a place where you can actually manage it and do some metadata implementation like the Kubernetes stuff, then fluent-bit might be more your match. And again, there's a performance piece to take into mind, right? So as you deploy fluent-bit or fluent-d or fluent-bit, evaluate the performance of those applications and understand like what you're looking at there to ensure that you're getting the best of what you can, right? Like make sure that it's a reasonable implementation for what you're trying to achieve. All right, back to the docs. All really cool stuff. Boop. All right, what have we talked about? We talked about that. We did that part. We also talked about what's a fluent-bit. We are going to get into the Helm chart piece now and play with that. So, all right, so there is Helm repo lists. There is a Helm repo from Elastic where there's a Helm chart stored for fluent-bit, and I've gone ahead and added that to my configuration. Apparently, I didn't click on it hard enough. Control click. Well, yeah, that's not super helpful. Anyway, they have Helm charts for all the stuff that we've got deployed here. They've got a Helm chart for Elasticsearch. They've got a Helm chart for different versions of Elasticsearch, all kinds of interesting stuff. FileBeat, all the things from there. But they also have fluent-bit as part of their chart. And so if I move into the fluent-bit chart, I can see the values here and also a README. Let's go check out the fluent-bit chart online. So this is actually, I'm using the hub.kubeapps.com way to look at this chart. Oh, actually, did I pull it from? I'm sorry. Yeah, I'm actually pulling this chart from Kubernetes charts, not from, or from hub.charts, not from Elastic. I was looking at Elastic for something else. So if you go to kubeapps.com, hub.kubeapps.com, right, this is a way to see like a bunch of upstream charts that are hosted, and these charts are generally maintained, and we can see like who the maintainers of this chart are, right? So we have Kay Fox, we have Ed Siper, who's with us today. Eduardo Silva is a maintainer of this chart. We have Hector, um, and this is related to the fluent-bit.io. Right now, this chart is deploying, I think, 1.3.7 rather than 1.3.9, but we're going to play with it a little bit more. Now, I'm going to use the Helm chart to deploy fluent-bit because it actually allows me to take a few runs at how this will be configured. So let's go ahead and explore how that's going to work. So the way that I did this and the way that I typically work with Helm charts is I pull the chart down and I look at the values file, and it basically shows me what's here, right? So this particular Helm chart gives us the ability to understand and configure an Elasticsearch forward backend to like a webhook, an Elasticsearch backend, an HTTP backend, a Splunk backend, and a Stackdriver backend. And if you have the answers to these questions, then you can go ahead and configure it however you want. You can enable through the configuration here different parsers. There are a bunch of general annotations, like do you want to actually capture the audit logs? This is actually why I added the audit log to my cluster so that we could say, yeah, let's do that. Whether we want to capture the pod annotations or the labels, which I can't remember if those are on by default or not. And then it actually also configures some really interesting values, like the ability to override things from inside the system, right? So being able to override particular features, like this idea of enable exclude, right? So if I annotate a pod with fluent-bit.io/exclude true, then that means that the logs from that pod will not show up in my log aggregator. And that might be super useful if we think about how much we pay for log aggregation to like Splunk or some of these other companies. It gives us the ability to kind of like maybe manipulate that kind of directly. And you can enable that or not enable that, right? So if you feel like it's going to be used for not going to be used for good, then don't enable it. We have a kube URL. A bunch of these things are by default. We have kube tags. Got a bunch of other configurations, like what image fluent-bit tag is going to be used, what the repository is, if you're hosting it locally inside of your own image registry, what the image pull secret is if you care about that one. And then we have our input tail, parser, our path, what log files we want to grab, those sorts of things. These are inputs, and I believe that these can be specified multiple times, right? And you have RBAC create. This is really cool. I haven't seen this happen very often, but in this case, the chart, if you enable this, will actually deploy a pod security policy that is locked down to just those things that the particular pods need, which is actually pretty cool. And if you want to get really flexible with it, you can actually provide it a complete raw config. Bunch of other things that we can enable, metrics enable, track offsets, and that's the Helm chart. So that's quite a lot of capability in the Helm chart. Let's go ahead and deploy this thing and play with it. Now, Helm Template dot cat notes. So I was playing with this before, and in the interest of time, I'm going to play with this. I'm going to do this some more, but I'm going to jump in here and kind of like forward the clock a little bit. So what I've got is I'm using the Helm template command, which is part of Helm and Helm 3. I'm giving the name of the deployment, logging. This is a Helm 3 thing. Before you had to do -- name. I'm telling it to use the current directory as the chart directory. And then I'm overriding some of these variables, right? I'm overriding the set input systemd enabled to true because I do want to actually collect from systemd the output of those things that we were watching before. I'm telling it the multiple things I want it to watch. I only have containerd inside my host. I don't have Docker. So I want to watch the containerd service. And I also want to watch the kubelet service. I'm telling it the input tail parser is the CRI parser instead of the Docker parser, because again, I'm using containerd, not Docker. I'm telling it to set the backend type to Elasticsearch so that it will forward all of my things up to an Elasticsearch endpoint. And again, like here in the output, just like we saw in the configuration, where I'm setting the backend to elasticsearch-logging.kubesystem.service.cluster.local. And this is like an FQDN that can be used in any pod anywhere inside of this particular Kubernetes cluster to address the Elasticsearch logging deployment that I have. I've told it to go ahead and audit enable true, and I've given it a different tag, the 139 tag, which is the more recent tag of fluent-bit. So when we kick all that off, we can actually go ahead and take a look at the manifests that are going to be created. So we can see the release is called logging. We can see the name of the service account, right? This is the app, fluent-bit app. It's the name logging fluent-bit. We can see the secret that's being created. We can see the config.yaml for this. And so here is our fluent-bit configuration. It looks very similar to the fluent-bit for the fluent configuration that we saw before, in which we have our inputs. We're catching inputs from tail. We're watching var log container start.log. We told it to use the parser, the CRI parser. We're tagging it with cube.star. We have some configuration here for refresh interval and for the memory buffer limit and to skip long lines. We have a different input for systemd in which we're watching for the containerd service and the kubelet service. We're watching the input for tail again, right? This one was just systemd piece, where we're going to use journal kennel to interact with that log. And this one is actually using the tail log again to look for var log kube API server audit.log. We have a parser of Docker here. We'll see how that works out. Not sure if that'll work out at all, but we're going to take a look at it. And then the key here, the tag is audit, and the key is Kubernetes audit. And then we have our filter, right? So again, we're using a filter of Kubernetes. We're matching on the cube output, and that match comes from the input, right? Where we're actually setting the tag from that input. We're matching it, we're tagging all this data is cube. And here down in the filter layer, we're doing a match on cube. So anything coming from var log containers is actually match that. Here's actually how we're going to authenticate to Kubernetes itself to get that metadata. We're merging the login, we're grabbing the token from the service account, and all that good stuff. And then the output configuration, right? We're going to output to Elasticsearch. We're matching everything that fluent-d has at this point. We want to kick it all up. We're going to send that data to Elasticsearch logging kube system service cluster local on port 9200, logstash format on, logstash prefix Kubernetes cluster. That'll help us because we can actually see if we see this new index, right? So this will actually give us a different index. Before we saw the logstash one, now we're going to see the Kubernetes cluster one. Okay, here's the fluent-bit configuration. We're telling it the service, the input, the filter, the output, and those are all broken up across those other files. Here's our parsers, right? And we're going to see the parsers that we have. And here's our cluster role that's being defined. We're allowing get pods. This is actually the cluster role that fluent-bit is going to use to pull that metadata down from Kubernetes that it relates to these particular containers. And our role binding. And there's our daemon set for fluent-bit. And now here's something that's been bothering me. I didn't realize it before, but if you think about it, this particular line is actually innocuous. It doesn't do us anything because we're not using var log Docker containers. We're getting our data from var log containers. In fact, this mount seems superfluous. I actually just noticed this recently when I was playing with this log. But if we go up here, right, like where are we actually getting our logs? Our tail line and our input is var log containers. So we're not looking at varlib Docker containers. Nowhere in here, in this entire file, except for the mount point, are we actually addressing that mount point. Interesting stuff, right? So what that means is that we're actually gathering content from this thing that we don't need, right? So we're actually mounting a host path that we don't actually need here, and so we should probably get rid of that. But that was one thing I noticed about when I was looking through the manifest, is that it's actually mounting something that we don't need. And then he also has a test framework that allows us to understand whether we're actually seeing these things work. So we've got all this configured. Let's go ahead and deploy it. kubectl apply -f. Oh, kubectl create ns logging. Spell it correctly. All right. So now we've just applied that whole set of manifests. What do we see up here at the pods level? So let's do kubectl get pods -n logging. We're seeing the test thing fire up. We're seeing our fluent-bit deploying. Something's not quite right here. kubectl get pods -n logging. -a. Go wide. We only deployed this to workers. Bum, bum, bum. That's interesting. So the toleration doesn't match every host. It only matches the hosts that are not masters. So presumably, if we go back to our command here, we go down to our daemon set, that daemon set has no tolerations, which means that it won't apply to the master. Okay. Let's go back over here and look at our configuration and see if there's like something super easy to fix there. Host tolerations. So we could actually specify a toleration. But I am not going to worry about it for now. So let's keep going. Actually, I am going to worry about it because I want to make sure this runs on my API server as well, because right now it's not. So let's take a look at the values file. Operator exists. I don't think I can actually change. I'm being silly here. Logging. Okay, so logging has been cleaned up. Let's go ahead and edit our manifest. manifest.yaml. There we go. Daemon set. Okay. Oops. Put it in the wrong. Hey y'all, I'm back, I think. Hoping I'm back. Sorry about that. That was a fun one. Machine just rebooted on me. Good times. Hey. Yeah, that was wild. All right. That was unfortunate. So it's almost 2:40, but I want to actually finish this up. I want to show this a little bit more. So I'm going to run through this real quick, and we'll see how far we get. So I appreciate you sticking around about this one. I realized that was like a pretty intense place to lose it. So we'll do kind, delete cluster. So let's jump through this real quick. CD kind create cluster config. That was a tough one. We'll be back up in a jiff though, so sorry about that. That was pretty wild. So we'll get this deployed again. That was pretty wild. I don't think I've ever seen that happen before. Relatively new laptop. I'm not sure what actually caused the failure, but like, yeah, it just basically rebooted on me right in the middle of things. It might have been that I was actually manipulating like the file system too quickly across different namespaces in the same Linux kernel, and I might have like found a little kernel exploit there, as it were, but hard to say. Oh, shoot, that's not going to work actually. Delete cluster, CP, kind, temp. Create cluster config. There we go. That's better. Yeah, probably could have brought another machine to do it, but I'm glad you all are still with me. We'll be back up here. What just happened was I realized I didn't put the advanced audit log piece back in the temp file system, so the control plane couldn't start. So then I replaced it. Now we're back in play. Getting the worker nodes brought up here. Okay, now we got a cluster up, history, grep, kind of load. Kubernetes cluster, move Kubernetes cluster add-ons, Kibana, Fluent, Elasticsearch here. RM Fluent, yes, star. Okay, got images, kind load, Docker image. Pop these on there. Oh, actually, that's a great question. Let me pull it up. Thank you. Mr. Josh Rosso taught me that trick. What is it called? Octets. So Josh put up a post a while ago that was, boom, this thing. Vim Kubernetes YAML support, which I thought was really cool. This is using the language server that can be used on a variety of different IDEs. I use Vim for my editor, and so it was neat. I'm actually using this same setup to do it. So if you're interested in exploring that, definitely check that out, Eduardo. It's very cool. It's yeah, I really like it a lot. It's actually the fanciest my Vim setup has been in a very long time. Get all apply-f kubectl get pods -n kube system grep minus v running. Give that a sec to start up here. But yeah, the COC and if you can do Go pull it, you can use Go completion, all kinds of cool stuff. So yeah, I'm actually planning on doing a session on this coming up in one of the new episodes. I'm planning on doing like a development setup for Kubernetes, and that's part of what I'm going to show. But yeah, it's pretty killer. I'm really digging the new language server. All right. Get pods -n kube system grep Kibana. I want to see that come up, which we'll do as soon as the other Elasticsearch endpoint is up. Okay, restarted it twice now. Get pod -n kube system. And Elasticsearch 0 is up, Elasticsearch 1 is up, Kibana is probably just about to be up. And we're up. All right, so Kibana's back, Elasticsearch is back, kubectl proxy, kubectl proxy is back, cat notes. Actually, here's our manifest YAML from before. We're in good shape there, so let's go ahead and reapply this. Kubectl apply -f manifest. Kubectl get pods. Kubectl apply -f manifest -- namespace equals logging. All right. Get pods -n logging. That's better. Okay, so now kubectl get pods -n logging -o wide. We can see that we're running on the master as well, the control plane node as well, and that's awesome. But what I was about to show you before I was so rudely interrupted was why that's working that way. And so I want to share with you what this is. This is actually a really cool thing. So this toleration, I wish we were all a little bit more like this toleration. This toleration means tolerate everything. It means if it doesn't matter what it is, what the toleration is, it means just it's a Borgism. It means tolerate everything. So anywhere there's a node, put this pod there. Doesn't matter what's on it, doesn't matter how it's tainted, just put it there. If there's a kubelet there and it's registered with the cluster, put this pod on that kubelet. That's what this means. That's what tolerations operator exists mean. So pretty neat feature, a pretty kind of a superpower of tolerations. I see a lot of people trying to define tolerations that match like the different configurations of clusters. This is the simplest. Sometimes the simplest is the best. This is the simplest way to do that. All right, cool. So now let's take a look at our indices. Let's do 4. Okay, so before we saw a Logstash one, now we see the Kubernetes cluster one, and that is actually output coming from our new fluent-bit daemon set. So let's go ahead and do our XDG open. Let's do our XDG open again. And again, we're going to jump into the Kibana logging endpoint. When I look at that output, this is actually pretty cool because it means if I see the index, it means I've got everything working, right? If I don't see an index, it means that there's nothing working and it's not going to give me a good time. But I think we are past that. So because it's a brand new install of Elasticsearch, I have to again kind of pick my index name. Otherwise, I would have had to go back and actually add a new index. And that's fine. Next. Our timestamp is going to be timestamp. We got so many fields, 605 fields. And here is our log coming from fluent-bit. I want to look at tags. That's neat. All right, so here is logs from the, that's cool. So these are actually logs from our Kubernetes cluster that are a part of our audit logs. Oh, it's actually this is just probably part of the Kibana stuff. So So right now we only have like, not very many pods deployed. We didn't put our log generator back up there, but we can see that there are, 5 pods, the CondNet network pods, and the Kibana logging pod generating logs. We got some source IPs being captured by something. I'm curious what that's about. So let's go ahead and dig into that one. This is kind of the fun part about logs. You can dig into it a little bit more and figure out what's happening. So, here. So this is actually coming from our log of the audit.kh.io version, right? So that is awesome. Kind event. I'm looking for the tag though, and I'm not seeing the tagging. I must be missing something. Right, like I see the log event, which is awesome, but I'm looking for a way to disambiguate this type of log from all of the rest. And so when we actually specified our tags, I would have thought that that would have actually pulled that up. But for some reason, I don't see it. But anyway, this output is actually coming from the audit log generated by the API server sitting on that control plane node. And it's broken it up into things like decision allow, reason, and like some of the content that is actually being captured by the Kubernetes audit log. And yet another really great thing to get the heck off of your control plane node, right? Like you shouldn't have your audit log hosted on your control plane node, because if it goes away, then you no longer have an audit log that describes what's happening. But with that audit log, we can see who made what command, when they did it, like what their response was, whether we allowed that in, what the source IP address of that was. Lots of really good information to see, right? So these are basically just a get command. And so this is all just a way of expressing the configuration of, this is actually just looking at the output of your current deployment of fluent-bit. So that's, I guess, what I wanted to show you. What I'm going to do is I'm going to make available everything that I've actually done here. So this whole directory, which includes the kind configuration, the Kubernetes manifests, fluent-bit, Fluent Elasticsearch, the log generator files, and my notes are all going to be inside of the repository for this particular talk. But yeah, that's what I wanted to show you. I guess there was one more thing that I noticed, which was kind of a weird heads up thing. So let's take a look at that real quick. If I look for kubelet logs, tag, maybe, no. So these logs are from the kubelet authentication log. Let's actually, you know what, let's do this. Let's do history grep log gen. Kettle scale deployment. Replicas 5. Get pods. So now we got our log gens going. Let's go back to our aggregator and look for log gen. So now we're going to see stuff like the logs coming from the log gen output. We're going to be able to see when they get when that log gets created, or we're going to be able to see like the different lines. Kubelet log gen. Yeah, struggling with log output is a different game, but I'm not going to play it right now. Anyway, we're able to see like the logs from all of the things that are happening inside of here now, and that's really cool. The last thing I wanted to show you was that basically what I learned was that Debian by default doesn't persist logs to disk. And so if I were to jump into the worker node, var log journal. So this is actually where journal keeps all of its logs, but only if they're made persistent. By default, they are not. And so what I noticed before was I wasn't able to actually get those outputs, right? So if I do journal kettle minus flu kubelet, right, and I look for this, line, IO28. Just kind of like reverse engineer our way into this. Right, so this is a message coming from the kubelet. And that's actually pretty powerful. It gives us the ability to understand, like, that's actually standard error off of KindNet. That's not what I was looking for. Anyway, we should be able to see the logs from the kubelet and from container D running. So it's clearly not specific enough. This will probably be specific enough. Let's try that. There we go. All right, so that is from the kubelet. Syslog identifier kubelet. That's actually coming from the kubelet. We can see that content. So all of our things are actually showing up. And so what I noticed before was I wasn't getting those outputs. And so I needed to actually change the configuration to make sure that they're not in a different index. They're part of a different syslog identifier. So I think that's actually where I missed it. So like in this case, it's actually syslog identifier kubelet. But yeah, so like this is the remove filter syslog. Yeah. Oh, anyway, brutal. That's what I wanted to show you. I hope that was helpful. I'm going to sign off, but yeah, like right now they're not in a different index. We could actually make it so that they were, though, by providing a different output. At the moment, they're all on the same output. But yeah, that's what I wanted to show you. I hope that was helpful. Let me kick back over here to the big screen. Yeah. All right. Thank you all very much. That was a long episode. I'm sorry that the reboot got us, but we got back on our feet pretty quickly and got things working again. I hope that was really helpful, and I look forward to seeing you next time. Thanks again for all of your help, and I hope all of this stuff isn't like too wild, but I look forward to seeing a bunch of you in Amsterdam. If you have not met me in person, please feel free to come by and say hello. I'll be probably at the booth, or I have a couple of presentations. I love to meet people who are who are out there in the space trying to do good things, and so it's been a pleasure. I am Maui Lion on Twitter. I hope you all have a kicking weekend, and I look forward to presenting to you next time. I'll see you all next time.